PreAP, PreCalculus, Notes Section 3.2, Solving Polynomial Equations and Inequalities. Here's what our goal is for this section. We want to be able to take a function or an inequality, like this down here, really what we want to do. We want to be able to determine for what x values is this going to be true. We want to be able to do this without looking at a graph. Now, in order to gain an understanding of how this works, we're going to look at the graph so that when we get this answer, it makes sense to us. But our ultimate goal is to be able to solve an inequality like this without using a graph. So let's take some baby steps here. The graph of the function f of x is pictured below. It's pictured right here. Factor f of x and use the factors to find the zeros. So we are supposed to factor, use the factors to find the zeros. So it looks like three things, these two things are combined. So to factor this, let's set it equal to 0. And that's how we find zeros, by setting it equal to 0. Let's factor out the greatest common factor. This is a trinomial. Is it a perfect square trinomial? It is not, because although this is a perfect square, this is not. Since the lead coefficient is 1, we can go directly into factoring this trinomial into two binomials. We take this x squared and we break it apart evenly so that the first term in each of our binomials is x. We're now looking for two numbers that multiply to get -6 and add to get +1. That would be, excuse me, a -2, nope, yeah, a -2 and a +3. Let me confirm, because for some reason my 6's I get messed up with. Should it be a 1 and 5 or a 2 and a 3? -2 times +3 is -6. That checks out. -2 plus 3 is a +1. All right, so I did that correctly. I don't always do that correctly. Set each factor equal to 0. And let's confirm that we actually followed the directions. Factor, did it. Use the factors to find the zeros. We did it. So we are suggesting that the zeros of this function are -3, 2, and 0. -3, 2, and 0. So we are correct. Using the graph, identify the values of x which each of the following equations or inequalities are true. F of x is equal to 0. This is asking for the zeros of the function, the x-intercepts. When is y 0? Well, we just found those. Using the graph, it's -3, 0, and 2. When is f of x bigger than 0? In other words, when is y positive? In other words, when is the graph above the x-axis? Well, it's above the x-axis from -3 to 0, non-inclusive, and from 2 to infinity. I'm going to go directly to question 4 now, which is asking, when is the function equal to 0 or positive? So when does the graph touch the x-axis, or when is it above it? Well, it's the answers that we just had, plus we have to include the -3, 0, and 2, because that's where it touches the x-axis, is where it's equal to 0. So it's from -3 to 0, inclusive, in union with inclusive 2 to infinity. Infinity is not a number, it's never included. If you look at these answers, the only difference between the two is us including or not including the end point of our interval. Since this includes the x-axis, we're including the numbers in our interval. This does not include the x-axis, so we're getting as close to it as we can. Sorry about that, I'm trying to erase. All right, when is f of x less than 0? When is y less than 0? When is y negative? When is the graph below the x-axis? That's what it's asking for. It is below the x-axis to the left of -3 and between 0 and 2, all non-inclusive. So that's negative infinity to -3, and then from 0 to 2. All non-inclusive. Question 3 and 5, I should say, are very closely related. 5 says, when is the graph equal to the x-axis or below it? When is it on the x-axis or below it? So it's what we had just highlighted here, plus -3, 0, and 2. So we're going to go negative infinity to -3 inclusive in union with 0 to 2, both inclusive. If you compare these answers, the only thing that's different is whether we're including or not including the endpoint. All right, now the work that we just did for this does not help us do the actual problems that we are setting out to do, but it is going to help us understand if what we did makes any sense. So we'll come back to this in a moment. For now, forget that it exists. Let's look at an analytical method by which we could solve a polynomial inequality. It's identical to the method that you learned in Algebra 2. Well, maybe or maybe not. I don't teach Algebra 2, so I probably shouldn't say that. If you didn't learn this in Algebra 2, it's fine. There's 1,000 different ways to do things, and whether you've seen this method or not, it doesn't matter. I will try to explain it as if you've never seen it before. So here are 4 steps. Step 1, completely factor the given polynomial, provided that it's not already factored. Well, look, we already did this. I'm just going to copy this down and put it down here. You are welcome. If you don't want to write this down again, just draw an arrow that, hey, you've already done this. Set each factor equal to 0 to find the zeros of the function. So we did that. So step 1 was to factor it completely. We did that. Step 2, set each factor equal to 0 and solve. That's here. Step 2 is also draw a number line that is divided into segments using the zeros. So we haven't done that. So we'll try to do that here. You're going to put these zeros on in ascending order from smallest to biggest. So we have 3 of these. We're going to have 3 little dashes. -3 is the smallest. 0 is the middle, and 2 is the biggest. Those are the x-intercepts, the zeros. So this is also step 2. Step 3. There's a lot of words here, but this isn't as complicated as it's going to seem. Choose a number from each interval. And let's do that first of all. Choose a number from each of these intervals. There are 4 intervals. There are 3 dividing points. That makes 4 different intervals. So I'm going to choose an x value here of -10, an x value of -1, an x value of 1, and an x value of 10. So I just chose a number from each interval. The number you choose doesn't matter. Determine the sign of each factor of the polynomial based upon the given value. This will enable you to determine if the entire polynomial is positive, negative, or 0. So we are looking specifically at this little fella right here. This is what we want. And you know what? Oh, 1 second. I just had a thought. So here's the thought that I had I should mention. I copied this stuff down here and brought it down here. When you are solving for these x values, we want to find the zeros. So because we want to find the zeros, we are going to set this equal to 0, even if this was an inequality. Now we're going to fix the inequality part. This just tells us where it crosses the x-axis. This inequality part is going to come into play. That's what we're using this table for down here. So yes, this was greater than or equal to, and I replaced it with an equal sign. We're going to likely do that every time. Okay, so getting back to this factored version. If I put a negative 10 in here for this x, is that x going to be negative or positive? It's not a trick question. It's a negative 10, it's going to be negative. If I put a negative 10 into this, a negative 10 minus 2, is that going to be positive or negative? It's going to be negative. If I put a negative 10 in here for x plus 3, a negative 10 plus 3, is that positive or negative? That's also negative. If you multiply 3 negatives together, you're going to get a negative answer. Going to bring this down, divide this, and divide this, and divide this. All right, so x, I'll tell you what, just to be consistent with how I have it on the notes and homework, I made these dashed. There's nuances of why you might want it to make it dashed or make it solid. I will ignore those nuances and just always do it dashed. If I put a negative 1 into x, that's going to be negative. If I put a negative 1 into this, negative 1 minus 2, still negative. If I put a negative 1 into this, negative 1 plus 3, well, that's positive. If you multiply two negatives and a positive, you're going to get a positive answer. If I put the test point in of 1, it's going to be positive. This is going to be negative, and this is going to be positive. We're going to have a positive, negative, positive. Sometimes I write too big. I'll write this down here. Negative. Is that what I said? Negative. Let me put this back in here. No, positive, negative, positive. If I multiply two positives and a negative, I'm going to get a negative. If I put the 10 into this, positive, positive, they're all three going to be positive. So plus, 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 multiply three positives, you're going to get a positive. All right, step 4. Refer to the original inequality sign. That is this fella right here. In this particular example, the inequality symbol is greater than or equal to, which means the solution will be the values that make the polynomial equal to 0 or positive. So this here is saying that f of x is greater than or equal to 0. That means, in as few words as possible, it means non-negative. Now you might see non-negative and think, well, you just mean positive. Well, it's more than positive. 0 is not negative and it's not positive. So if I say non-negative, I'm including 0 and positives. So if I just highlight this, when is it equal to 0? Here, here, here. When is it positive? On this interval and this interval. So if I write that down in interval notation, it's -3 to 0 inclusive in union with 2 to infinity. Now let's compare that. Did this answer appear any place up here? Sure did. It appeared right here. It's the same answer. Now you might be thinking, why did we do all this work to get the same answer? Because we're not always going to have this graph. So this question was, when is f of x equal to 0 or higher than it? Well, we can look at the graph and see this highlighted spots are when it's equal to 0 or bigger than it. This is an analytical way to do it. You practice this a few thousand times and it's not so bad. Let's do a second example together. Everything's set up the same as it was for the previous one. Graph is shown. Factor g of x. Use the factors to determine the zeros of the function. All right, well, let's do that. I'm going to factor out, actually, no, there's no GCF here. I'm going to set this equal to 0. I'm going to factor by grouping. Since the second group is all positive and the first group has negatives in it, I'm going to factor a negative out of the first group. I'm going to factor a negative x squared out, leaving me with x plus 3. GCF of the second group is 2, leaving me with x plus 3. Each of these have a factor, or pardon me, have a factor of x plus 3. So the GCF is an x plus 3, leaving me with negative x squared plus 2. There's reason for us to say we should factor a negative 1 out of this. I'm going to do that. It's going to make that nicer. 0 equals negative x plus 3 times x squared minus 2. I factored a negative out of this and I wrote it in front. This is a binomial and it's a difference, but this is a perfect square, but the 2 is not a perfect square, so it does not factor more. Set each factor equal to 0. 0 equals negative 1. No, it doesn't. That doesn't really count as anything. X plus 3 equals 0 is going to give us x equals negative 3. X squared minus 2 equals 0. We get x squared is 2. And we get x is plus or minus the square root of 2. So this is a false 0. This is a true 0, and this is 2 zeros. Using the graph, identify where the zeros are and yada, yada, yada. Using this graph to identify the zeros is not possible. This one appears to be negative 3. That's possible. This one appears to be between negative 1 and 2. I don't know what it actually is. That's why we did this work up here. It's negative square root of 2. This one we'd have to estimate as well, but we don't have to because we found it up here. So our x-intercepts from left to right are negative 3, negative square root of 2, and positive square root of 2. When is the graph above the x-axis? That's what that's asking. It's above the x-axis on the highlighted areas, which is negative infinity to negative 3, not inclusive, in union with this x-intercept of negative square root of 2 to the next x-intercept of positive square root of 2. I'm going to do this question next. When is the graph on the x-axis or above it? Well, I just take the endpoints that were numbers and I make those inclusive. When is the graph below the x-axis? It's below between the first pair of x-intercepts and after the last one. So it's below from negative 3 to negative square root of 2 in union with square root of 2 to infinity. 3 and 5 are closely related. When is it below the x-axis or on the x-axis? So I take my answer from number 3 and I include the endpoints. Cool. All right, now we get to what the point of this is, which is let's do this without a graph. Now before I do this without a graph, I'm going to include some of this stuff down here. And I suggest you do the same. Completely factor the given polynomial. We already did that. So I'm just going to bring down the completely factored version. And then the other part that it asks you to do is set each factor equal to 0 and solve it. We've already done that. So we had x-intercepts of negative 3, negative square root of 2, and positive square root of 2. Notice once again, even though it says less than, we just made it an equal sign. And if you prefer for me to put this over here, that's better for your OCD-ness, or maybe better for my OCD-ness. We can put it there. In other words, we want to set the boundary equal to 0 and solving it. The boundary is when it's equal to 0. Now we make a number line. On this number line, we make as many dashes as we have zeros. We have 3 zeros. It's not always going to be 3. We have one at negative 3, negative square root of 2, and positive square root of 2. You then pick a test point in each of these intervals. Let me make sure my intervals are clearly defined. To the left of negative 3, I just chose negative 10 again. Between negative 3 and negative square root of 2, I chose negative 2. Between negative square root of 2 and square root of 2, I chose 0. And to the right of the square root of 2, I chose 10. We're then going to take this test point, we're going to plug it in to the factored version of this. Now keep in mind the way I have this written, there are 3 terms, 3 factors, 1, 2, 3. This first one's negative every time. So I have a negative one followed by 2 terms that might be positive or negative. I have a negative one followed by something that's positive or negative. It's always negative, that first one, because it's a negative 1 out front. No matter what number you put in for x, it is not going to change that. If I put a negative 10 in for this, it's going to be negative. Negative 10 squared is a positive, 100. 100 minus 2 is positive. So I'm going to have negative, positive, multiply these together, it's going to be positive. It's above the x-axis. And if you look at our graph, we can confirm to the left of negative 3, it's above. So that makes sense. If I put a negative 2 into this, negative 2 plus 3 is positive. Negative 2 squared is a positive 4. Positive 4 minus 2 is positive. So the product of these is negative. We would expect the graph between negative 3 and negative square root of 2 to be below the x-axis. It is. Confirmed. If I put a 0 in, 0 plus 3 is positive. 0 squared minus 2 is negative. If you multiply a positive and 2 negatives, you're going to get a positive. So we expect between these roots, these square roots, it's above the x-axis. It is. Everything's working out the way we expect it to. If I put a 10 in, 10 plus 3 is positive. 10 squared minus 2 is also positive. We have this negative out in front. If you multiply those, you get a negative. We expect the end of the graph to be below the x-axis. It is. Now the question is, what are we trying to find? Well, this is g of x, and it's less than 0. So we need to state what that means. G of x is less than 0 means we're looking for negative things. We're looking for when it's below the x-axis, it's negative. It is negative between negative 3 and negative square root of 2, not inclusive, and it's negative to the right of square root of 2. Since there's no equal sign, it's not less than or equal to, we are not including the endpoints. So it's negative 3 to negative square root of 2, non-inclusive, in union with square root of 2 to infinity. Looking at our graph, that all makes sense. I'm going to stop the video here, and I'm going to make another short one that has 2 more examples.